So today I'm going to talk about climate change and shrinking bison, an imminent nutritional cascade. When we think about climate change, we tend to think about the world getting warmer. And although we know the world is getting warmer, the consequences of that warming are uncertain. When we think about bison, North American bison, we're especially uncertain about the consequences of warming for these animals. Generally, when people are trying to predict the effects of climate on the performance of animals like bison, we think about the direct effects. As it gets hotter, they might have trouble thermoregulating, or this might cause them undue stress. But there are other pathways by which climate can affect the performance of grazers like bisons. For example, affecting the quantity of food that's produced in a given year. In addition, changes in climate can also affect the quality of the food that's being produced. Changes in the quality of the grass that bison eat. And it's that I want to focus on today, is how climate is likely to cascade to the performance of animals by changing nutritional quality of the food that bison eat. As we start to try and predict how climate change is going to affect the performance of bison, our experiments really are of limited utility. The effect of bison on grasslands is really intense, and so understanding how climate change affects ungrazed grasslands doesn't necessarily translate to grazed areas. And if we try and use an experiment like putting heating lamps out there to heat the grasslands, we really can't heat a large enough area to incorporate all of the feedbacks that bison have on grasslands. So if we can't use experiments, we then need to turn to other techniques, such as comparing different sites using cross-site comparisons. And in this case, we would compare cold sites and hot sites and use hot sites as an index of the future, as a placeholder for what we think warmer grasslands are going to be like. Now, first I'm going to show you some data that look at continental patterns of bison weight. And for that, I looked at 22 different herds. And at each place, each of these different herds, the bison were weighed in the fall, so we could compare their weights at the same time of year. This is almost 300,000 weights of bison spread out across those 22 herds and across multiple years. When we take a look at the patterns of bison weight over time, on the x-axis here, I'm going to show you the age of the bison, and these are for female bison. On the y-axis is their weight, their mass, and here we're looking at that in kilograms. And I'm going to compare two trajectories of weight gain over time. The first is for a cold site, and the second is for a hot site. If we take a look at the cold site, for example, this is the rate of weight gain over time, and by the time these animals are 7, 8, 9, 10 years, they're on the order of 550 kilograms. If we look at the hot site, in their first year, the animals are smaller and they gain weight at a lower rate, such that by the time they hit their mature weight, they might only be somewhere on the order of 400 kilograms. So that's a difference of approximately 150 kilograms. So the consequence of warming temperatures for bison is going to be smaller animals. For the females, we saw about 150 kilograms difference across this really broad scale that we looked. For the males, it was even greater. If we compared a cold site and a hot site, differences were on the order of 300 kilograms. And for these two sites, we're comparing maybe South Dakota and Oklahoma were the two sites that we were comparing. So we know just by looking across sites that warming shrinks bison. If we have a warmer world, we can expect smaller bison. But how is that? What are the mechanisms by which this occurs? Well, to do that, we're then going to take a look at the underlying drivers of weight gain for animals, and we're going to look at the patterns of nutritional quality in grass at that same scale. Generally, when we're talking about nutritional quality for grazers, we're thinking about protein concentrations. Bison will eat grass in order to get energy and protein, but generally there's enough energy in the grass, and it's the protein concentrations that are most limiting to how much weight they gain. Trying to understand the quality of the grass that they're eating, the protein concentrations of their food, it's difficult to watch bison and then go out and collect plants, the same plants that they were eating, because they're selective grazers. So instead of watching them and then collecting grass, we actually get it at the other end. So we can take a look at fecal samples from bison and then use a technique, near-infrared spectroscopy, to take a look at essentially the chemical structure of that fecal material and infer the quality, the protein concentrations of the grass that those bison were eating. Now at the continental scale, we don't have data for bison, but we do have data for cattle, and we're going to use that as an analog to understand changes in nutritional quality of grass along those same gradients. This here is a map of all the sites for which, in one analysis that we did, fecal samples from cattle had been collected and nutritional quality had been determined. So there's somewhere on the order of 20,000 fecal samples that had been collected across all of these sites on the scale for the US. And we're going to look at that for different ecoregions and compare those. So this would be the northern shortgrass ecoregion, for example. Here are the sandhills of Nebraska. Here are the flint hills of Kansas, and the different grassland ecoregions that we have in Texas, for example. And this gradient here goes from cold to hot, which is going to give us an analog for what happens in the future as the world warms. Now for each of these ecoregions, essentially what we did is we took all the data that we had, and this shows us a time course of nutritional quality over the course of the year. On the x-axis, I have the day of year, so starting in January all the way to the end of the year. On the y-axis, we have crude protein concentrations, and really we can just take a look at this qualitatively. And what we see is when we do a best fit line through here, we're going to see the quality increase and then decrease over time. Now for each of these ecoregions, we did the same analysis, and we took a look at essentially the maximum crude protein concentration that the animals experienced during the year. We used that and then compared that across all the ecoregions to understand how nutritional quality varied with climate. Now I'll leave out some details, but if we put together a map of nutritional quality, what we see that on this map, red represents relatively high nutritional quality, blue is low, and as we work across our gradient from cold to hot, we see that nutritional quality goes down. So taking a look at this scale, at the continental scale, there are broad patterns in how good the grass is to eat, and then by proxy, what the nutritional stress is of animals. As we get from a colder system into a hotter system, what we're going to find is that hotter places have lower protein concentrations, and these lower protein concentrations allow animals to gain weight at a lower rate or constrain their growth. So taking these two things and putting them together, what does the future hold for bison? Well, we know there's going to be a warmer world. That's happening already, and our grasslands are warming up. And the consequence of having a warmer world is that we're going to have lower protein concentrations in grass. Those lower protein concentrations in grass are going to cause us to have smaller bison. In addition to having smaller animals, them gaining weight at a lower rate, we also expect them to reproduce at a lower rate, so having constraints at the population level. So in summary, if you want to see large bison, and everyone deserves to see these animals out on the prairie in their full size, the tips that I have: first, move north, and second, hurry up, because as those grasslands warm, those animals are going to have a harder time putting on weight, and we can expect to see smaller and smaller bison as they shrink due to greater nutritional stress in the future.